That's true. All you need is food.
Don't insult the booster. My dad loves to play on.
Yeah.
Katrina and I have decided on what we should do. We should just put everyone's idea.
Everyone's idea on it. We'll even take the MB kids' ideas. Everyone will
We don't make
Won't that be like expensive?
think it's very small. We can't affiliate it. So.
Alright, kids, here we go.
people look lower actually.
What's the alternate?
That's only tape on my mouth.
I'm ready. Here we go. There exists a perfect rectangle. That sounds worse. She can't do it. I thought she could. Alright.
Now it's worse.
If f is continuous in some sort of interval, kiddos, this is one form, which is okay. But it can also show up in another form. What would happen if we rearrange this? The perfect rectangle actually comes from the alternate way of writing it, which would be f of c times b minus a equals the integral from a to b of f of x dx. Why am I saying a perfect rectangle from the rearrangement of MBT? It could come either way.
That's not height.
Because we have a height
And that's the base.
times the base
Is equal.
equals the area under the curve. Now, is it any base times height? Hopefully we can all say resoundingly, no, not any base.
The one it's.
Well, sorry, any height. The base is established. The base is between A and B. It is what it is.
The one it's.
But there is a special C within A to B. Hey, MBT, there exists an F equals C within A to B such that. But in this one, it's such that there's a perfect height on the curve such that that base times height would be the exact same thing as the integral from B to B. But another way of writing it, this is the way that we see the perfect rectangle. But this way, hold on, who's this formula? 1 over b minus a equals the integral from a to b of f of x. Who is that? So the average value of f, who's f of c then?
The function at one point.
One kind of height.
The constant.
It's C.
Yeah, it's
It's the slope.
Depends on how you look at it.
Depends on the function.
One way of looking at it is the average value of f is going to equal some f value, right? But guys, if you think about one application, remember, one, because there's so many different ones. Yes, I use motion a lot because it's the easiest one for us to relate to with position and velocity and acceleration. We have the original first derivative, second derivative. So I'm going to use motion as the example. It could be any illustration like we talked about yesterday. But if we're taking the integral of something, can't we think of this something as a derivative? Like a rate. So we can say average value of a rate. So average rate is going to equal, if f is a rate, wouldn't this be an instantaneous rate?
Yeah.
So average rate equals instantaneous rate. That is MBT. Average equals instantaneous. So if we think about f as being a rate, then we can apply average rate equals instantaneous rate for at least one C in between A to B. But the dilemma is, what if this isn't a rate? What if this is temperature? So the average temperature is going to have to equal the actual temperature at least one point. Doesn't that make sense?
Yes.
Okay, hold on. How? Not how. What is the temperature outside right now?
110 degrees.
You can look at your Snapchat filter and it might be close.
I guess
Right? You can go to Weather Underground and check it out. Are you going to check it out?
I'll tell you right now.
83. Carl's Apple Watch said it. Yeah, because
Oh,
Kyle has an
83?
iPhone. Yeah, he has an
Okay.
Apple Watch. Yeah.
Let's see if Snap is the same. So 83 degrees. Okay. How could you figure out the average temperature of today?
You add all of the,
The actual temperature right now is 83-ish.
But you
yeah.
can.
To find the average, you have to add together all the different temperatures at all the different times today,
Then divide.
and then divide by all the different.
You can take it every hour.
It would be in
every hour.
So you could approximate by figuring out the temperature, and like I send someone outside with a thermometer. What is it? And every like half hour, every hour going out, and then we could add them all up and divide by how many increments we did. Yes, we could do that. Is that going to be precise?
No.
No. We would need a function, or we would need a lot more points to be able to get a better approximate of the average temperature. But let's say we figured out the average temperature of today to be, let's say, from 6 o'clock this morning to 6 o'clock tonight. It's not like during the night hours. Let's say the average temperature is something like 78.
Chill day.
I was thinking like the morning and then the night. I don't know. It's kind of warm. Maybe it'd be more like 80. Anyway, coming back. Question. What would this theorem tell us if the average temperature is 78?
Average, I have one.
That's not-
At least one time, it had to be 78 outside.
Even if it's
That makes sense.
Was that like the bonus?
yeah, it was.
Yeah.
So then coming back.
Some.
IBT for integration. It can be seen as a perfect rectangle.
Yeah, you can see
Please.
Yeah, do it. He's not talking about the sweatshirt. It can be seen as a perfect rectangle, or it can be seen as an average equaling an actual. An average equaling an actual at least once. Okay, antiderivative. We talked about this already. Whoa, wait a minute. Hold on. What's that?
Derivative of an integral? Because you're undoing it. First,
Oh, no.
the derivative.
I remember this.
I remember this somewhat.
Oh, this was FTC.
I remember this. FTC part 2.
Part 2.
But the book called it part 1.
Yeah.
Part 4. Part 5.
Wait, so why did we?
So FTC, the idea is that we're taking the derivative of an integral, but it's in, wait. What's the name of this integral? We have a name for this now when it's a constant to a variable. It's technically called the
Indefinite integral.
accumulator. The accumulator. So we take the derivative of the accumulator, you should get f of x. But how? Can't we say that the top one would equal antiderivative of x minus antiderivative of a? Isn't that true?
Yeah.
What's the derivative of the antiderivative?
A function or the original
The original function value. And what's the derivative of the... So we remember why this is true, right? What changes when you have an upper bound of u?
U prime.
Oh,
U.
When you go to take the derivative, you would have f of u times u prime left over.
Yeah, let's go.
How do you know it's a u? Because this is something other than just plain old x.
Let's go.
What if the integral is from x to a? Then you
Flip it. Flip it.
you have to flip it before you use your rule. You can have a negative instead. Okay, so reminding you of that idea.
Aw, dang it.
So that all leads into the idea of an antiderivative. We briefly talked about it last chapter. It was like in homework, I think. We didn't even talk about it in notes.
Miss D, is this the last section of like written notes? Like the page?
Oh, let me check.
For that examples?
The last section, I don't remember, but we have a test on Tuesday.
I just want the last page.
Which is why our correction.
Okay.
We're on purpose.
No, it's not.
Yeah, it is.
I mean, it's...
Can we okay, everyone talk a lot, so we take an extra day, so we use the test one.
We have been used to release. Okay, so anyway,
I
antiderivative
can squeeze this, I can squeeze.
Or work really fast.
is a function such that the derivative equals the integrand, right? And then we can use FTC in order to solve a definite interval.
Yeah, great.
Ooh, 50. That would be an inside joke.
About the sweatshirt. Take it.
It's a visual reminder.
No, but it was good though, Miss D.
Oh, you don't have to actually put it on.
He's gonna put it on. Do it. No, please, you might end up ripping out some skin cells.
Question, what's the antiderivative of e to the x? Antiderivative of e to the x. Come on, guys, this one's easy.
dx.
No plus c. We're doing a definite interval. So e to the 1 minus e to the 0 is
E to the 1 plus or minus 1.
minus 1, right? Don't forget FTC.
Oh, you 0.
Number 24, antiderivative.
X cubed. Plus 1.
9. 9.
Ausfahrt.
Lachen, weinen zu jeder Kirche. It's a German song that we sing in here.
Oh my gosh, I
It has to do with like some flowers.
Wait, can you speak German?
No, just the one song that we memorize, and that's all I
That's my
remember.
favorite German song.
My favorite German song is Disco Pogo.
But is it called Peter?
No, it's not.
That's what
I didn't have to breathe.
I don't even know what the
That's
tune
right.
is. That's
Peter
just that.
Rackle.
Okay. Antiderivatives, we're finding the oh, guys, this section, are the antiderivatives gonna get complicated?
Yeah.
No. What? Do they need U sub? No, but they might introduce U sub in a couple homework problems. A few of you guys were talking about that yesterday. It might show up, but technically we're not doing it yet because next section, we get to get into a little bit more detail and the antiderivatives will get a bit more complicated. Okay, basically. Here's workspace, let's go. Let's see, it doesn't seem that bad, right? Antiderivatives, and then we have MPT, integration, average value. Workspace, let's see how we do. And then let's talk about sweatshirts. So first of all, workspace. I did, I'll go get my reminder.
Wordspace will be in. Can I write in a colored pen? The flow of the pen is a lot smoother. It's easier to write.
All right. Time limit, let's go ahead and give you guys, let's see, we have 3 multiple choice, which should be 1.2 minutes each.
5 minutes.
And then free response, this one's not a full free response. Yeah, let's do 5 minutes. Ready, set, go. It's okay, he's got it. This is going all the way back to section 6.1. So 6.1 to 6.3, everything from Riemann sums to basic integral properties. Okay, go, go, go. Yeah.
What if an answer we got?
Maybe it's a different form. No, we're all here.
He has a 0 to 20.
4, right?
There is a 0 to 20.
Thanks, Corey. I'm on.
Yeah, I couldn't answer.
Talk to your group. Talk to yourself.
Yeah, I'll talk to you.
True, but if you already talked to someone, you talk to your
I
group.
don't think this group wants to talk to him. I mean, just close to me. I just realized why it's 0 to 1. And I feel really dumb. I put the final thing is yeah. I was thinking
What you need is
I
28.
was thinking C, that's what I was thinking.
No, what you need is 20. You get a 1 at the end. No, but if you plug in 1, it's the first one. I'm guessing it's 20.
An answer that wasn't on the board.
Is that 2 the K? Is that 2 the K for 3? I can't see. I had 2 the K. Yes.
Okay,
No, just regular K, Kyle. Which one did you get for Kyle? Sorry, Kyle. I forgot you're not the apologize. Just Z.
Oh, it was so funny. Yeah, I did.
So, 3? Wait, so oh, it's 2. Whoops. Why is it subtracting? You're adding 3. Oh, minus plus 3. I'm guessing 3 is 8 plus 2b plus 3b minus 8. Oh, I did. 3b. I got it.
Wait, why is it 3 minus 3?
Yeah, because you separate.
Plus 3b minus. Oh, because you're just saying number. It's all yo.
Wait, so 3? Wait.
Yeah.
3 is here.
Oh,
Because you have negative 2 and
yeah, you can put negative 2 and it's still positive. Wait.
No.
Oh, I hate myself. Why do you hate yourself? Wait, I think you're right. No, wait.
Okay, 3 is really simple.
Actually, no, yeah.
3 is C.
It has to be C.
Because the full, if it goes from A to A, is equal to 0. Yes, it's also 3.
Yeah, but if you plug in back here, it's only the value that works.
It's literally just the rule, from A to A. How does that work?
So it's C.
It seems right.
You
Oh,
actually
think that right after
it'd be negative 8 plus positive. Well, it can't be.
It's a
Because that's just a normal property. That's sucking. And then that is, I've never read one of these questions. I thought that it's still an if. I hate you.
Hey, no, is that F double prime though?
Ha 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 ha.
That's what I thought.
You tell me.
Wait, it's 10 to 11.
Oh, that's. How do you spell it?
4x plus 1. 2 minus 2. Can you do that? Yeah, but
No.
plus C.
I didn't see anything. So he did send you.
You sure about that, dude? In case 6.
I think you can use it to find C, because you're gonna need to find C, but multiple second derivative. So you just integrate that, and then you can use that to find C.
Oh, just once. Can you find the slope at 0? Wait, 0 to 5?
Why would it,
Wait,
why would it?
Actually, it works out the other way.
If we only need to integrate those second derivatives, then why would
maybe that function.
Oh, I figured it out, bro. You have to double prime.
I don't know what the word. I just integrated. Plugged in.
Yeah, you felt
So I'm
safe.
to find my and then found the right.
Oh,
He's doing it and she's erasing. Don't call me. What would I do?
No, cost integration. It gives you Kyle, why are you choosing?
That's like that.
Oh, wait.
What do we get up five, 7? Oh, it's 4?
Wow, what?
See, told you if I'd see. Oh, you weren't even disagreeing. So Miss T, the points is, Miss T's a X is 0, right? 0, negative 5.
So you plug in 0. This is your F prime. You have to plug in the slope, not the y.
Oh my goodness. Okay. Oh, I get it now. Okay.
Oh, CS4. Okay, She integrated it and I'm sorry. Don't you have to integrate it again? Oh.
Wait, is it decimals or decimals?
Okay. I get it. I don't want to do it. Oh, I did.
No, like decimals. It's decimals. No, it's not. No, it's not. Because I got this battle with this Christmas I just started singing Deck the Halls and you were like, excuse me, but it's Deck the Halls. Really appreciate it. Excuse me that. And I just really weirded out. It's nice to weird snacks. Every time it's going in, I'm gonna get this. We should get some comments. This is supposed to happen. I'm gonna be so fucking tired. Wait, yo, what's that? How is she integrating like that? I'm sorry. What about
I need a
Alright, what have you guys, which are the ones have you guys, what should I say, verified? All of them?
So F0
How many of you guys verified number 1 to be D?
Yeah.
Yeah.
Raise your hand.
Oh, no.
Gracias. Okay. How do you guys verify number 2 to be B?
Could you explain?
Okay, number 2, do you see how there are 20 different approximations, 20 different rectangles, 20 different subintervals?
Yeah.
Okay, so it's been split into 20ths. What has been split into 20ths? The base is the B minus, what's the good way to say this? The base of the rectangles is 1/20th. What cut into 20ths would give you 1/20th? From 0 to 1. Another way of looking at it is, if you go from 0 to 1, cutting that into 20ths, wouldn't you have 1/20th, 2/20th, 3/20th, 4/20th, 5/20th, which is what they're plugging in as x?
That makes sense.
So n is equal to 20, which is what I put up there. N is equal to 20. There are 20 subintervals, but if you cut an interval into 20ths, what would your actual x values be? Well, guys, if they're going from 1/20th to 2, they end at 1 and they start at 0. They end at 1 and they start at 0. Those are your x bounds. That's your A and your B.
So it goes from 0 to 20, but the 120.
If it was 0 to 20 and you're still doing 20 rectangles, then your base would be 1. Does that make sense? Your base would be 1, so you have square root of 1, square root of 2, square root all the way up to square root of 20. But these are just going through the 20 different segments or separations or partitions, the subintervals from 0 to 1. So you have to look at, okay, what's the x at the end? That's just 1. So the 1/20, we don't want that because this is base and this is height. This is just a rectangle. There is no extra constant, so that one doesn't make sense. None of those three make sense. This is just base times height. And then if you're looking at it, we're not doing over 20, we're doing the 20ths as we go through all of our different subintervals. That's why B is incorrect. It's the only one that would make sense if you actually go to solve it with n equals 20. Number 3, has that been verified to be 2?
Yeah.
Cool.
Wait, why?
That's an even function. Or just a function from A to A. Function from A to A is equal to 0, so you know that's 2.
Oh, okay, you can think of it that way too. That's true. I just solved it. But yeah, you could say from 2 to 2 is 0, so then that would be the easiest one. But you might need to think about -2, but since it is the even function, what's on the right is on the left, so it would be double. It wouldn't be 0. If you think about like the actual graph. Okay, last but not least, number 4. Question. What was the key for letter A? A tangent line uses which derivative? First. How do I get to the first derivative from the second? One antiderivative. And then you set the first derivative, which had a plus c in and of itself. I had to set that equal to, what was the clue from this guy? The slope is 4. So I knew that the first derivative had to equal 4 when x was 0. That's the first clue, to get the first plus c in that first integration. Then I was able to get 4. Then I had to integrate again to get f. And what's the clue I used for that one? X and y. To solve. Then the average value, I went ahead and just took and plugged in. Did you guys verify, first of all, the f of x to be plus 4x minus 5? X cubed plus 6x squared? Yeah. Okay. And then did you verify the negative 23/8 on your calculator or by hand? Negative 3 even? I'm missing an 8. I'm not sure what that means.
An 8. Like an 8. 1 day rule.
How? 2 plus 2 is 4. 4 minus 5 is -1. -1 plus a fourth is -3/4, right? And then minus 1/4 minus 2 plus 2 plus 5. 5 plus a fourth. Wouldn't that be 24th plus 1/4 is 21/4?
24 fourths. So you get 6.
Oh, I just can't add. Is that what you meant?
Oh, yes.
Yeah, I just can't add.
Why is it over 8?
Because I have the 2 on the outside, the 1/2 from the 1 over b minus a.
Oh, that is right there.
Okay, there we go. right, thanks, kiddos. So now we verified cause.
Wait, I have
Time
a
out.
question. Why did you integrate again for
Oh, because average value of F, remember an average value says take who they're asking.
Oh, okay.
Exactly. Like if they wanted the average temperature outside, we would need a function for temperature and then 1 over b minus a, the integral of temperature, which is hard in our brains, but yes, we need to go back in the partition. All right. This brings us up to section 6.4, which would be nice for us to start, but let's go ahead and pause real quick.
Homework?